Hi, I'm Trace,
And I'm Anya.
and this is our presentation on uranium 235.
So, uranium has the elemental symbol of U. Its atomic number is 92. It's got a molecular weight of 235 grams per mole, and it's actually got a half life of 704 million years. So, it's not going anywhere anytime soon.
So, what exactly is uranium 235? Uranium is a naturally occurring radioactive element that has no stable isotope. Naturally occurring uranium is composed of only three major isotopes: 238, 235, and 234. All three isotopes are radioactive, and the most stable abundant is 238, which has a half life of 4.5 billion years. Uranium 235 is an isotope of uranium, making up only 0.72% of natural uranium.
So, quick joke. What do Twinkies and uranium 235 have in common?
What's that?
They both have a half life of about 704 million years. So uranium was actually 235 specifically was actually discovered in 1935 by Canadian American physicist Arthur Jeffrey Dempster. Man has two first names and the last name of almost Dumpster.
Dumpster.
So before discovering it, he was actually known more for developing the first modern mass spectrometer in 1918, which helped scientists to identify compounds based on their mass. And his research actually centered on the mass spectrometer, helped him find uranium 235 actually.
So, what is a mass spectrometer? A perfect explanation can be found in the scientific journal Current Science, volume 120, volume or issue 5. A current beam under vacuum is passed through a uranium sample. Uranium ions get accelerated and move through with the current. This ion beam then passes through a magnetic sector where it gets dispersed based on the mass to charge ratio of the ions. The separated beams are collected and converted to voltages. A comparison of the voltage reveals the isotope ratios in the sample.
This is basically just a lot of words kind of saying, we shoot the light makes the beams. That tells you how much there is.
Yep. So, why use uranium 235? Well, unlike uranium's more stable isotope 238, 235 is a fissile isotope, meaning it is able to sustain a fission chain reaction. A fission chain reaction is a sequence of reactions where the reactive product allows additional reactions to take place, creating a positive feedback loop that self amplifies. U235 is the only fissile isotope that is found in significant quality in nature.
So, in power plants, we use heavy water reactors and some graphite moderated reactors, and they can use natural uranium, but the light water ones use that low enriched ones because of the higher neutron absorption of the light water.
Uranium enrichment removes some of the uranium 238 and increases the proportion of uranium 235. Highly enriched uranium, or HEUs, which contains an even greater proportion of uranium 235, is sometimes used in the reactors of nuclear submarines, research reactors, and nuclear weapons. On August the 6th, 1945, the Little Boy gun type atomic weapon was dropped on Hiroshima. The Little Boy was created with highly enriched uranium. The material used was 85% or more of uranium 235 and is known as weapons grade uranium. Though for a crude and inefficient weapon, only 20% enrichment is sufficient, which is called weapons usable.
So, if you guys want to find yourself some 20% enriched uranium, go ahead, I guess. It just won't be weapons grade, apparently.
Just don't use the 85.
So, we actually have the anatomy of a thermonuclear warhead, just for fun.
In case you needed it.
Yeah, so most actually use plutonium 239 as the fissile component of the primary stage, but they also use highly enriched uranium frequently for the secondary stage so that it makes sure, you can actually, do the damage that you really need to.
So here we have a diagram of the warhead. So at the very front of the warhead, you have the uranium 235, which is the secondary stage. But in the very back, we have the plutonium 239, which is the major big boom that you see. So, were you exposed to uranium? How do you know? Well, natural uranium can be found in rocks, soil, and water and is naturally radioactive. The primary source of uranium exposure is through well water, though modern day manufacturing and nuclear energy have contributed to the amount of uranium making its way into our water and natural environment. Uranium can also stick to plant roots, so food grown in uranium rich soils can also be contaminated.
And that's where you get into the Fallout games, where
Ooh.
everything's got radium and uranium and everything in it.
So, chemical toxicity. The main chemical effect associated with exposure to uranium and its compounds is kidney toxicity. This can be caused by breathing air containing uranium dust or by eating substances containing uranium, which then enters the bloodstream. Once in the bloodstream, the uranium compounds are filtered through the kidneys where they can cause damage to the kidney cells. Very high uranium intakes of 50 to 150 milligrams can cause acute kidney failure and death. At lower intake levels, 25 to 40 milligrams, damage can be detected by the presence of protein and dead cells in the urine, but no other symptoms are reported. Also, at lower intake levels, the kidney repairs itself over a period of several weeks after the uranium exposure has stopped.
So while there's also chemical toxicity, there is radiological toxicity. So there are several possible health effects that are associated with human exposure to radiation from uranium, but because all uranium isotopes mainly emit alpha particles, they don't really have much penetrating ability. The main radiation hazard comes from ingested or inhaled, as talked about with the chemical. However, workers in a vicinity of large quantities of uranium in storage or in a processing facility are also exposed to levels of external radiation from uranium decay products. So, at the exposure levels typically associated with the handling of uranium, the primary radiation health effect of concern is an increased probability of the exposed individual developing cancer during their lifetime. So that's why a lot of like the Chernobyl stuff or 3 Mile Island, it's going to be
Mm-hmm.
cancer. So cancer cases induced by radiation are generally indistinguishable from other naturally occurring cancers that occur years after the exposure takes place. So the probability of developing a radiation-induced cancer increases with increased uranium intake.
Mm-hmm.
So here we have someone who obviously didn't pay attention and is holding uranium with his raw hand, just bare hand, and uranium. But here we have the chemical effects versus the radiation effects. So chemical effects, you get a lot high blood pressure, obviously kidney disease. The kidney really takes a beating from uranium.
Mm-hmm.
You can also get reproductive impairment and problems. And with the radiation effects, that's where the cancers come in. So you can get again reduced kidney function, bone cancer, or lung cancer.
In the medical journal The Chemistry and Toxicology of Depleted Uranium by Sidney Katz, it was reported that Desert Storm veterans were exposed to depleted uranium from shrapnel. It is stated that urinary uranium concentrations ranged from 10 to over 500 times the normal levels. The veterans' high urinary uranium concentrations were consistent with biomarkers of renal proximal tubular cell function and cytotoxicity associated with elevated urinary protein excretion. So, the symptoms of uranium toxicity: so bleeding gums, cancer, bone deterioration, hair loss, kidney disease, mental health decay, including anxiety, depression, abnormal increase of REM sleep, nervous system problems, and reproductive issues.
You guys know this one. This is Chernobyl disaster. So on April 25th, 1986, the worst nuclear accident in history unfolded in northern Ukraine as a reactor at a nuclear power plant exploded. So more than 30 years after that incident, scientists estimate the zone will still not be habitable for up to 20,000 years. During routine maintenance, two power surges caused the chain reaction of explosions inside the plant, which left the nuclear core exposed, just spewing radioactive material into the atmosphere. Up to 30% of Chernobyl's 190 metric tons of uranium was now in the atmosphere, and the Soviet Union eventually evacuated the 335,000 people living there, establishing a 19-mile wide exclusion zone around the reactor. At least 28 people initially died as a result of the accident, while more than 100 were injured. International researchers have predicted that ultimately around 4,000 people exposed to high levels of radiation could succumb to radiation related cancer, while about 5,000 people exposed to lower levels of radiation may suffer the same fate. And like we said with the cancer, it's hard to distinguish regular cancer versus radiation
Mm-hmm.
cancer. So I mean, if you were in Chernobyl when this happened, it's probably radiation cancer, but you
Yeah.
know, don't go to Chernobyl.
Well, here are a list of our references for this presentation.
And I hope you guys enjoyed this.
And we'll leave you a one last little joke.
Yeah.